Here's the interface for the Masa Life toolset. I've loaded up one of the demos they provide, which is a simulation of 2 dogs and a mailman. The AI system is based on decision trees, as you see here, some of which can be really simple, like the mailman's tree, while others, like the tree for the dogs, can get more complex, as seen here. The dogs have several decisions they can make. They can spot a mailman and bark at him. They can locate a bone and dig it up. Or they can simply just wander around. While running the simulation, you can suspend it at any time. Doing this will highlight the most recent path taken through a decision tree. It can be rather helpful. You can see an example of this here. So let's take a look at the miner implementation in Masa Life. As you can see here, the toolset also allows you to speed up or slow down the simulation multiple times. We can see the miner traveling from place to place, verbalizing his actions as he did in Buckland's code. He'll urinate, he'll mine, he'll go to the bank, and eventually, he'll get tired and go home to rest. Like in Buckland's code, as soon as he's well rested, he'll return right back to mining. Now let's take a look at the miner's decision tree. As you can see, it's a bit more complex than what we saw in the demo, but it's still not too bad. It provides a fairly modular way to encapsulate the logic behind the AI's decisions. One of the pitfalls, however, was that it seemed impossible to do something as simple as increment of values stored in a variable. The toolset works mainly with Boolean values, so states such as urinating were activated based on chance. Masa Life provides a feature called verbose, which is what the miner is using to narrate his actions. We can see an example of this in the go home and sleep node, where he says, "I'm a bit tired, I'll head home," right there in that box. Alright, so if we take a look over here on the right, we can see the final action of the mine for gold tree is mine. This is actually calling an embedded decision tree called mine labeling. This tree is where a random selector is used to change the Boolean values associated with collecting nuggets and filling the miner's bladder. Now let's take a look at the goalie implementation. Since the goalie relies on interaction with a moving ball, 2 entities were implemented. The ball, which you can see moving in and out of the goal, and the goalie, who you can see moving to block the ball. Most of the time, the goalie does a pretty good job. The ball's decision tree looks pretty simple. Obviously, what it's doing is essentially choosing locations and going to those locations. You can see some more examples of the verbose feature here as well, as the ball reports when it's aiming and when it's resetting. But what I really want to focus on here is the node for selecting a destination, which just so happens to be another embedded decision tree. We'll take a look at that tree now. Now before I talk about anything else in this embedded tree, I want to point out this little node on the left. This is an example of messaging in Masa Life. Here, we are subscribing for the ready message. When the ball gets that message, it uses a random selector to choose a path through this tree. Each path leads to a different choice of a destination. Once the destination is chosen, the ball will send out a ready message, as seen here. Finally, we'll wrap up with the goalie's tree. It's pretty simple. When the goalie hears that the ball is ready, he will track the location of the ball and move to intercept it.